Inverse functions. Our objective, we want to define what an inverse function is and verify that two functions are the inverse of one another. So what do we know coming in? Well, we know what an inverse operation is. An inverse operation is an operation that undoes another operation. So for example, addition undoes subtraction, subtraction undoes addition. The same goes for multiplication and division. They undo one another. And the same goes for squares and square roots. They undo one another. So we've worked with inverse operations, so inverse functions are going to have the same idea. We also know about composite functions. A composite function is a function made up of other functions, usually it's a function made up of another function. So you usually have two, where the output of one is the input of the other. For example, f of g of x. All right, so we've talked about inverse operations. Let's define an inverse function. An inverse function, just like I alluded to, is a function that undoes a given function. And I've got a few ways to show this to you. Let's take the function 2x plus 3, and we're going to write it in a flow diagram. So x goes in, and the first thing we do is multiply it by 2, order of operations. Out comes the answer, which is 2 times whatever, it's doubled. We then add 3 to that, and out comes 2x plus 3. The inverse function simply goes the other way. So suppose we put the y in from the other side. Instead of adding 3, we would subtract 3. Out would come y minus 3. And then instead of multiplying by 2, we would divide by 2. And out would come y minus 3 divided by 2. So that's a flow diagram method of showing the inverse of the function 2x plus 3 is undone by the function y minus 3 divided by 2. Okay, notation. Let me get my paper straight here for you. Notation. Inverse functions are denoted with a raised -1. Okay, the negative sign has lots of meanings in mathematics. Here's another one. Okay, if you have a -1 that's been raised, like we see here, it stands for an inverse. So if the function is called f, the inverse is called f inverse. F raised to the -1. It's read f inverse. So again, that negative symbol has lots of meanings in mathematics. It totally depends on how it's used. Gotta get used to that. All right, let me get myself together here. Okay, here's another diagram for us. So the neat thing about an inverse is that it'll give us back the original value. Okay, same thing with adding and subtracting. You get back to where you were. Well, if an apple goes into the function and magic happens and out comes a banana, if the banana goes into the inverse function, f inverse, it'll give you back the apple, so to speak, okay? So if the f function turns the apple to a banana, the inverse function, f inverse, turns the banana back to the apple. Okay, just another probably silly way of looking at it, but that might help you remember it a little bit. So what is the definition in mathematics of the inverse of a function? If f and g are two functions such that f of g of x is equal to x and g of f of x is equal to x. So you do the g function first and then the f function, and out comes x. And you do the f function first and then the g function, and also out comes x. Then g is the inverse of f. And we can rename g f inverse. Okay, so in other words, f of f inverse of x equals x and f inverse of f of x equals x, the domain of f is equal to the range of f inverse and vice versa. The range of f is equal to the domain of f inverse. We'll see that at some points later on. Okay, so we have the definition, both in words and kind of in math speak. Let's verify whether two functions are inverses of one another. To do that, we've got these two functions, an f function and a g function. We simply need to show this right here. If we do the g function first and then the f function, do we get x? And if we do the f function first and then the g function, do we get x? If both of these are true, then f and g are inverses of one another, and we can rename g f inverse. Let's do an example. This is fairly straightforward. Okay, so we want to verify that the function f of x equals 3x plus 2 and the function g of x is equal to x minus 2 over 3 are inverses of one another. So by verify, we know they are. Okay, we're verifying it. We know they're inverses of one another. Let's prove that by going up to here and showing that f of g of x is x and g of f of x is x. Okay, so let's first let's write that down. We want to show, first we want to show A, that f of g of x is equal to x, and then we want to show B that g of f of x is equal to x. If those two things are true, and we know they are because we're verifying, then we know they're inverses of one another. So let's do A. F of g of x. So the g of x function is going to go first. G of x is here. This is the same as f of g of x. I'll substitute g of x with x minus 2 over 3. Okay, so I want to put x minus 2 over 3 into the f function, which means this is equal to 3 times the input, x minus 2 over 3 plus 2. So I put the g function into the f function. Now I'll do some math. Well, this cancels. I'm left with x minus 2 plus 2 because the 3 in the numerator and the 3 in the denominator factor out. And of course, this is just x. So I just verified that f of g of x is x. Right there, we verified it. Now, is g of f of x also x? Okay, right here. So let's verify that. G of f of x. Well, that's g of, the input is f of x this time, which is here. So I'll replace f of x with its expression, 3x plus 2. Let's put 3x plus 2 into the g function. So I'll have 3x plus 2 minus 2 over 3. I put 3x plus 2 right there into the g function. And this, of course, gives me, well, 3x plus 2 minus 2 is 3x in the numerator. And I have 3 in the denominator, and that simplifies to x. There you go. I have just verified that these two functions are inverses of one another by showing that the composition f of g of x is x and the composition g of f of x is x. And we can say down here, because g is the inverse of f, which we knew that was true here because it said verify, and we just did. Okay, because g is inverse, we can use inverse notation. And write, instead of writing them as f and g, let me slide my paper up here, we can write f of x is 3x plus 2. which is right up here. But instead of writing g of x, since we know g of x is the inverse, we can replace the g of x with f inverse of x is equal to x, minus 2, right there. I was going to write a plus over 3. So because we know they're inverses, we can note that to people using inverse notation and say that this is f of x and this is f inverse of x is x minus 2. We can do the same thing with g. We could say this is g of x and this is g inverse if we wanted to, but normally the f is our main function. So there you have it, a little bit about functions, inverses, what they are, and how to verify whether or not two functions are inverses of one another.